In today's video, I want to show you the relationship between 45, 45, 90 right triangles. So before we start, you must be familiar with the Pythagorean theorem. And I want to show you how these two sides relate to this third side. Okay, so here we have an isosceles triangle, and we know that because in isosceles triangles, base angles are equal, and this is an isosceles right triangle. And since it is isosceles, we know that this side is congruent to this side. And let's go ahead and label that. Label that. Let me do it better. Let me use my line tool. And there, and we know that's congruent. And let's go ahead and label the vertices of the triangle. Not that color. I just want it like that. Okay, let's label the vertices. Let's call this side A, not with that tool, with my brush, A, B, C. Okay, and let's call these two sides X. And we're trying to figure out what the relationship between these sides is. Alright, so let's use the Pythagorean theorem. And let's call this side A. And we want to express, actually, let's call it something different. Let's call it Z. So we want to find the relationship between the X's and the Z's. And we want to write Z in terms of X. So let's go ahead and do that. So let's remember the Pythagorean theorem, what it says. It says that the squares of the two legs, the sum of the squares of the two legs, is equal to the square of the hypotenuse. So let's go ahead and write that down. X squared plus, so let's do this x squared first, this one right here, x squared, and then plus the other x squared is equal to z squared, which is the hypotenuse. Okay, now let's go ahead and try to simplify that. So on the left, we can combine the two terms, and we get 2 x squared is equal to z squared. And to solve for z, all we have to do is take the square root of both. So we have the square root of this and the square root of that. The square root of z squared, remember we're taking the principal square root, so it's positive. We have positive z. And the square root of 2 times x squared is the square root of 2 times x. So up here we have z is equal to the square root of 2 times x. So if you know this, you could just multiply it by the square root of 2 to get x. So let's we could be finished with the video right here if that's all you want to know, but I'll just show you a couple of examples about how this works. You don't need to continue watching if you don't want to. Okay, so let's say we have a triangle right here. And we're just going to go through 2 really quick examples. And let's call this side 3 and this side 3. And let's find what this side over here is, x. Let's call that x. Or actually, sure, let's call it a. Okay, so we know 3 squared plus 3 squared is equal to a. That looks like a 9. Equal to a. And we have 3 squared plus 3 squared is 18 because 3 squared is 9. 18 is equal to, oh, I forgot to square a over here. 18 is equal to a squared. And we take the square root of both sides and we get the square root of 18 is equal to a. And then we can simplify that and we have the square root of 9 times 2 is equal to a. And then we have the square root of 9 times the square root of 2 is equal to a. And 3 square root 2 is equal to a. And let's go back up here, and we know a is equal to 3 square root 2. Remember, that's the relationship only if this is 45, this is 45 degrees, and this is 90 degrees. So remember, all you have to do is multiply one of the legs by the square root of 2 to get the hypotenuse. Now try to find the relationship between a 30, 60, 90 triangle. Thanks for watching.